section 17.6. It is the last section in chapter 17 with radicals, okay? And what we're going to do is we're going to use radical equations, learn how to solve them, and as well as the word problems, but these are probably the easiest word problems you've seen. So each of the word problems have been kind of hard, but this is one of the easier sections. So let's look at the instructions. It says, in order to solve a radical equation, the first thing we must do is we have to isolate one radical on one side of the equation. So it's very similar to the absolute value equations. If you remember, we isolated the absolute value equation and then we broke them out of the bars. It's going to be the same idea here. So we're going to isolate the radical, and then once we look at that, we ask ourselves, what kind of radical do we have? Do we have a square root or cube root or whatever? Because what we're going to do is we're going to arrange each side to the equation to the power equal to the index. So if it's a square root, we're going to square it. If it's a cube root, we're going to cube it, and so forth. And we're going to go from there. If we do have a second radical, we're going to have to repeat steps 1 and 2. There's one that we have that, but I'll show you what's going on, okay? And then key thing here, we do need to check our solutions because sometimes we get extra solutions. They're called extraneous solutions that are not part of the answer, all right? So let's look at number 1. Here's our radical, right? We want to isolate him. So we want that radical to be the only thing on that side of the equal sign. So who must we move? The 1, right? And we do it with opposite operations. What's the opposite of subtracting 1? We're going to add 1 over, okay? So we have the square root of v plus 2. Whoa. That's just in time for Halloween. All right. So we have the square root of v plus 2 equals 1. And at this point, it seems kind of like magic, but I can show you why it works. In order to get rid of a square root, you need a pair, right? You need 2 of something. And so what we're going to do is we're actually going to square this left side, but if you square the left, we just got to make sure we square the right. And I'll just tell you the shortcut. Whenever you take a root to the appropriate index, they undo each other, but why? What's squaring v plus 2? You would have square root of v plus 2, the square root of v plus 2. You have a pair of v plus 2's, and so they would come out of the square root. So just realize whenever you raise a square root to a squared power, they undo each other. They're inverse operations. So the inside, v plus 2, comes out. And on the right, what's 1 squared? 1. And at that point, you can solve for v by just subtracting 2 over. So you get v equals -1. Before I circle it or put it in my math lab, I just double check it by putting it back in here. -1 plus 2 is 1. What's the square root of 1? 1. 1 minus 1 is 0. So that's the right answer. Okay? But again, the reason why this works, and you don't have to do it, but I just want to tell you, when we do that, that's just the square root of v plus 2 times the square root of v plus 2. Okay? But that just means we have 2 v plus 2's under the radical. And what do we know about a square root? If you have a pair, it comes out, okay? So that's kind of a long way of doing it, but just realize that they undo each other. You have the right amount so they can come out and play. All right, number 2, we're going to do the exact same way, guys. Here's our radical. We must isolate him first, so what's the next move we're going to make? Add the 8 over. So we have the square root of x minus 4 equals a positive 2. What's the opposite of square rooting? Squaring. But if we square the left, we have to square the right. And I do rewrite it as a second step because sometimes if you don't, you think like, how did I get there? You know, like, where did that come from? So I do write it as a second step. All right, what happens when you square a square root? They undo each other, so who pops out? X minus 4. What's the square of 2? 4. And our last move is to what? Add 4 over. So you have x equals 8. And again, before I circle it or put it in my math lab, I'll just put it up here real quick. 8 minus 4 is 4, but what's the square root of 4? 2. What's 2 minus 8? -6. So you did it correctly. Okay, and I know I'm doing that in my head, but feel free to throw that into your calculator. Are there any questions on 1 or 2? Not too bad. On 3, we have two square roots, but notice they're both on opposite sides, which is nice. So what happens if we would just square the left? Well, if we square the left, we have to square the right, but that's perfect. That's exactly what we want to happen. They're both square rooted, and they're both already isolated. So in both of these, when we square the square root, they undo each other. So the insides just bust out, all right? So we have 8x minus 5 equals 2x plus 8. And then that's an equation that you can just solve either way. I like to keep my x's positive, so I'm going to subtract 2x over here. I'm going to add 5 to over here. So I have 6x equals 13. Does that look right? So x equals 13 halves. Oops, 13 halves, 13 sixths. Okay? So I like to keep my x's positive, so I subtracted the 2x over here. Since I subtracted the 2x over here, I'm going to add the 5 to the other side. So you get 6x equals 13, so your last move is to divide by 6. If you put this in, I don't even know what it is, but you can put 8 times 13 6 minus 5, hit enter, and that should be the same thing as 2 times 13 6 plus 8. Those left will equal the right. So that is our final answer. Number 4 kind of looks like it, but what do you notice? That they're not isolated. They're both on the same side, right? So what can we do? We can actually add this guy over, right? The whole thing, we can move him over by adding him over, okay? So what are we going to have? We're going to have 8x plus 3 equals the square root of 6x plus 11. Right? If that was a negative 2, you would add 2 over. Well, it's a negative square root, so we'll add the square root over. And at that point, once we move them over, we made it look like number 3. So we can just square both sides, okay? So what's the square of the square root of x plus 3? And what's the square of the square root of 6x plus 11? The insides will come out, so you have 8x plus 3 equals 6x plus 11. At that point, I'm going to move my 6x over, but since I moved my 6x to the left, I'm going to move my 3 to the right. So I have 2x equals 8. So x equals 4. Does that look right? Okay. And again, you can go back up here. You have 8 times 4 is 32 plus 3 is 35. 6 times 4 is 24 plus 11 is 35. The square root of 35 minus square root of 35 is 0. So we have the right answer there. All right. If there's no questions on the front page, let's go ahead and see what happens when they get a little bit more difficult. So on the back, what we're going to notice is on number 5, our square root is already isolated. So it's what we like, okay? So how do we undo a square root? We must square it. But if we square the right to get rid of the square root, we have to square all of the left, which happens to be a binomial now, okay? So before we just had like a 3 there, so 3 squared was 9. But now we have y minus 3. So what are we going to have to do in order to square y minus 3? What is that? That is y minus 3 times y minus 3. Okay? So he's actually going to become the difficult side. The right side, what happens when you square square root, it cancels, so the inside, negative 4y plus 12, comes out. So on the left side, we'll have to FOIL, or in other terms, just distribute that y to both things, and then negative 3 to both things, right? So take this y, distribute it in there, you get y squared. Take this y, distribute it to a negative 3, you get a negative 3y. And we're done distributing our y, so we're going to move on to our negative 3. Negative 3 times y is a negative 3y, and negative 3 times negative 3 is a positive 9. All right. Now what we notice is that a square came out, which means a quadratic popped out. Whenever a quadratic comes out, it should remind you of chapter 13. Whenever you have a quadratic, you want to get everything to one side equal to 0, so you can use the AC method. But before I start moving stuff, I like to clear up the left side so we can combine like terms. So the two negative 3y's combine to be a negative 6y. All right. So I want to move everything to the left because I like to keep my y squared positive. So I'm going to move my negative 4y to the left by adding it to the 6y. And I'm going to move my 12 to the left by subtracting it. So I'm going to have y squared minus 2y minus 3 equals 0. Y squared minus 2y minus 3 equals 0. So what are we going to do now in order to solve this quadratic? What do we have to do? The AC method, okay? And again, just for purposes of this class, I'm going to kind of wave my wand. What are factors of negative 3 that add up to negative 2? Negative 3, positive 1, you would factor by regrouping, okay? And this would end up being y minus 3, y plus 1 equals 0. So what are our two potential answers? Y equals 3 and negative 1. Usually when a quadratic pops out, guys, and you come up with two answers, this is usually when one will work and one won't. So it's very important to check them, okay? So over here, let's try 3. On the left side, what do you get? What's 3 minus 3? 0. On the right side, what's negative 4 times 3? Negative 12. What's negative 12 plus 12? 0. What's the square root of 0? 0. 0 equals 0. So 3 works. But if you do it with negative 1, it's not going to work. Over here, negative 1 minus 3 is a negative 4. Here, a negative 1 times a negative 4 is a positive 4. A positive 4 plus 12 is 16. The square root of 16 is a positive 4. So we have a negative 4 equals a positive 4, which is not true. So the y equals 3 is really the only answer, okay? This gives us negative 4 equals positive 4, which is not true, okay? So you do have to change, and I'm doing it all like in my head, but feel free to put it in your calculator and get that to work out. Guys, 6 is the exact same idea, okay? Notice that our square root is already isolated, so we're just going to square both sides. But when we square the right, we're going to have w minus 4 squared completely. So on the left, he's the easy guy. When you square a square root, they undo each other. So you have negative 2w plus 11, but on the right-hand side, you're going to have the w minus 4 times the w minus 4. On the left, let the negative 2w plus 11 hang out. Let the negative 2w plus 11 hang out. And let's go ahead and FOIL or distribute the right-hand side, okay? So we're going to take w times both of these. So w times w gives you w squared. W times negative 4 gives you negative 4w. Negative 4 times w gives you another negative 4w. And negative 4 times negative 4 gives you positive 16. And again, what you'll notice is a square came out, so we're going to eventually move everything to the right. But before I do that, I'm going to gather like terms on the right. So the two negative 4's become a negative 8w. And if you can go right there, because you know that's what's going to happen, that's fine. Like if you don't have to do those two steps. Just make sure this is that's what you get for sitting in front. Alright, so what I'm going to do, guys, is I want to move everything to the right with my w squared, because I want to have it equal to 0 so I can use the AC method. So my 2 is negative, so I'm going to add 2w. And my 11 is positive, so I'm going to subtract it. So I have 0 equals w squared minus 6w plus 15. Does that look right? Oh, no, minus 11. So plus 5. And at that point, it's like chapter 13 when we have a quadratic equal to 0, so we need a factor. In this case, since it's a trinomial, we're going to factor by using the AC method. And again, just for purposes of this class, factors of 5 that add up to negative 6 are negative 5 and negative 1. So you factor by regrouping, and you get this w minus 5 times w minus 1. So what are our two potential answers? 5 and 1, but usually only one's going to work out, okay? So we got to try both of them. So we'll put 5 up here. Negative 2 times 5 is a negative 10. Negative 10 plus 11 is 1. The square root of 1 is 1. 5 minus 4 is 1. 1 equals 1. So 5 works for sure. Try 1. Negative 2 times 1 is negative 2, plus 11 is 9. What's the square root of 9? 3. But over here, you get that 1 minus 4 is negative 3. He does not work. 3 does not equal negative 3. So W equals 5. So whenever you get that quadratic where 2 pop out, usually only one's going to work. All right. So we've seen a lot of squares, but guess what? They really can give you any kind of root, okay? So they can give you cube roots, fourth roots, sixth roots, 100th roots. It doesn't matter. Because what you're going to do is the same thing. You're going to isolate your radical. You're going to isolate your radical, and then just raise it to the appropriate power. So in number 7, we want to get this cube root by himself, but who's in our way? 5. The 5. So we got to subtract him over. So we have the cube root of x plus 1 equals negative 2. And at this point, how do you get rid of a cube root? We haven't done it yet, but what's the opposite of cube rooting? Cubing, okay? If there's a fourth root, we raise it to the 4th power. So all we're going to do, guys, is cube both sides. On the left-hand side, cubing and cube root undoes each other because you'll have 3x plus 1s under the radical. So they'll pop out as x plus 1. On the right-hand side, what happens when you cube negative 2? What do you get? Negative 8. And at that point, to isolate x, what are we going to do? Just subtract the 1 over, okay? So once you do the cubing or the squaring or the 4th power, whatever, you're left with a normal equation, whether it be linear like this or quadratic like the 2 above. So we're just going to subtract that 1 over and we get negative 9. So let's make sure that works. If you put negative 9 up here, negative 9 plus 1 is negative 8. The cube root of negative 8 is negative 2. Negative 2 plus 5 is 3, so he works. One thing I want to point out, because I think it's on your worksheet, but there's not one on here, cube roots can equal negatives, because a negative of a cube root is negative, but if you ever get a square root equal to a negative, there's no real answer. For example, if this didn't have a negative 8 when we moved it over to make it a positive 2, if you just had a square root equal to a negative 6, it's not, you can't have a positive square root equal to a negative number, okay? So that would be no solution. I think there's one like that on your worksheet. So square roots can't equal negatives, but odd roots can, okay? All right, the last one, guys, he's just a bit tougher. So write a little small because we have to do steps 1 and 2 twice because there's 2 radicals here, okay? So write a little small. We're going to isolate him by subtracting him over here. So we have the square root of 2x plus 5 equals 3 minus the square root of 2x, like that. So we got one isolated, the square root of 2x plus 5, but we have to subtract the root 2x. I just put him in the back, okay? He's not a like term with the 3, so we can't combine them, all right? Now that we isolated one, we're going to square him. But if you square the left, you have to square the right, and this is where it gets a little yucky. The left side is the easy side. When you square square root, they undo each other. So 2x plus 5 is just going to pop out. The right side, though, that's kind of like the FOIL, right? So we're going to take 3 minus the square root of 2x times itself twice. And we're going to FOIL that bad boy. And this is good practice, though. Those that haven't finished 17.5 homework with, rationalizing the denominator, we have to do this kind of stuff quite often. So this will be good practice. All right. Let 2x plus 5 hang out as we FOIL this ugly thing. Remember the 3 is a whole number, so he will not go inside the root. He will just stay outside the root. The 2x, they're both under the root, so when we multiply them, they'll stay under the root. So we're going to have 3 times 3, which is 9. 3 times a negative root 2x, the 3 will stay out on the outside, and the root 2x will stay behind him. So we're done with that, okay? Now we're going to do negative root 2x times 3. Again, the 3 will stay on the outside of the root 2x. And then a negative times a negative will be a positive, and what do we have? 4x squared, because they're both under the root, so we can do the math. 2 times 2 is 4. X times x is x squared. 2x plus 5, guys, is still going to hang out with us as we try to clean this up, okay? We have 9. And we have like terms. We have 2 root 2x's, but we have negative 3, negative 3. So we have negative 6 root 2x's. And then what can we do with the square root of 4x squared? We can break it down. What's the square root of 4? 2, and what's the square root of x squared? X. So, even though it looks like we had a handful of roots there, we really didn't once we combined them and then once we broke them down. Okay, so we've done that steps 1 and 2 already. 1 was to isolate the radical, 2 was to erase it to appropriate power. But if you go back to the front, it says, if the equation still contains a radical, repeat steps 1 and 2 again, which means we need to isolate our radical. So we need to get this guy by himself, okay? So what I'm going to do is I'm going to move the 9 over, and I'm going to move the 2x over. What happens with our 2x's? They cancel. That's nice. We don't have to worry about them at all, okay? And what happens to the left side, you have 5 minus 9, or a negative 4, equals a negative 6 root 2x. All right. At this point, you're like, well, you just told me a square root can't equal a negative, but we have a negative square root equaling a negative, so that's okay, all right? So it's isolated. Let's go ahead and square both sides. So the square root of negative 4 and the square of negative 6 root 2x. If you wanted to, you guys could divide by negative 6 to get it completely isolated, but then you get turned into fractions, and so I'm like, well, just wait for the fraction at the end, okay? So as long as it's just the root with the coefficient, we have it isolated enough. All right, let's see if we can figure this out. What's negative 4 squared? What's 4 times 4? 16, right? And then over here, this is kind of interesting. What we're going to do, guys, is we have to square the negative 6. So what's 6 times 6? 36. But then we're going to square the square root, but we already know what happens when you square the square root. The inside just comes out. So we have 36 times 2x. I know that's kind of weird, but we square both parts, both the 6 and the root. So the 6 squared gives us 36. But the square of the square root undo each other, so 2x pops out. And what operation is this right here? Multiplication. So we have 16 equals whatever 36 times 2 is. What's 36 times 2, guys? 72. 72x. Awesome. Okay. At that point, it's a normal equation that you're used to solving. We're just going to divide both sides by 72. So x equals 16 over 72, but that does reduce. So in your calculator, do 16 over 72 and hit math frac to get the reduced answer. I think it's 2/9, is that right? So we do all that to get that final answer of 2/9, and just trust me, it does work, okay? So when we shove 2/9 in here and add 5 and take the square root of it, plus 2/9 times square root, it does equal 3. This is a little bit more complicated. I think I took it off of your homework, though. So you might not see that on the homework, but I just want to show you in case you see it. So that's the solving of equations. So in a nutshell, isolate the radical and just make sure you square, cube, whatever you need to do, all right? So these two little things down here are the word problems. And the word problems just consist of the Pythagorean theorem. So all we need to remember is that a squared plus b squared equals c squared, where a and b are the legs and c is that long diagonal, the hypotenuse, okay? So in this one, it's already drawn for us. So we have a leg and a leg equals a hypotenuse. So we're just going to have 4 squared plus b squared equals 10 squared, and we're going to solve for b. So PEMDAS, let's take care of our exponents first, right? What's 4 squared? 16. Do we know b? No, so he's going to stay b squared. And then what's 10 squared? 100. And then we want to get b by itself. Okay, so we want to get b by itself, so we're going to subtract the 16 over. So we get b squared equals 84. Is that okay so far? But if you look at what it says, find the length of the unknown leg, and the unknown leg is b, not b squared. So it's the opposite of what we were doing up here. Up here we wanted to get rid of roots, so we squared. But if you want to get rid of a square, you square root. They're opposite operations. So what we're going to do, guys, is we're going to take the square root of the left, and we're going to take the square root of the right. On the left, what do we know about squares and square roots? They undo each other. On the right, we're going to have to break him down. The first thing I would do is I'd put him in your calculator first. See if he's a perfect square. 84 is not a perfect square, but that's the first move I'm going to make, all right? Then let's go ahead and break him down. He is an even number, so 2 times what gets you 84? 42. And what are 2 numbers that multiply to be 42? 6 and 7. Okay. And what are 2 numbers that multiply to be 6? 2 and 3. And what am I looking for since it's a square root? How many things? 2. 2, right? Do you see 2 of anything? We sure do. So B is going to be what? Who gets to come out? 2. The 2. Who stays in? 3 times 7 or 21. And then what was the unit for the side? Meters. Okay? So what we did was we did our Pythagorean theorem, putting everything where we had. We had one leg, so the 4 squared was over here, and we had the hypotenuse, so 10 was over there. And then we isolated our b squared, but in order to get rid of a square, you take the square root, and then you break the root down accordingly. All right, 10 is the exact same idea. 10 is the exact same idea, except for we have to kind of configure what the triangle looks like based on the word problem. So it says a 50-foot supporting wire is to be attached to a 75-foot antenna. Because of surrounding buildings, sidewalks, and roadways, the wire must be anchored exactly 20 feet from the base of the antenna. How high from the base of the antenna is the wire attached? So we have the 75-foot wire, okay? But we have this wire, like, not attached at the top. It's, like, attached down here somewhere, and we don't know that, so that's X. What we do know is that we know the supporting wire is 50 foot, so that's the supporting wire right here, so 50 foot goes right here. And we also know that the wire is anchored exactly 20 feet from the base of the antenna, so here it's anchored, and here's 20 feet from the base, so 20 feet down there. So that 75-foot wire was false information, not false, but unneeded information. We didn't really care how big the antenna was. We just want to care where the wire hits the antenna, okay? And notice it's really similar to number 9, where we have one leg and the hypotenuse, okay? So this is going to be x squared plus 20 squared equals 50 squared. X squared plus 20 squared equals 50 squared. So we don't know what x is. He's going to say x squared. 20 squared, throw it in your calculator, you'll get 400. 50 squared, throw it in your calculator, you'll get 2,500. We want to get x squared by itself, so what do we need to do?
Minus 400.
Subtract 400 over. So you have x squared equals 2,100. At this point, we want to get that broken down, so we're going to take the square root of x squared, and we're going to take the square root of 2,100. What do you know about a number if there's double zero in it? What number goes into it? 10. Not even only 10, but 100, right? If there's 2 zeros, which means a 10 is going to pop out. So this is 100 times 21, which means we have a pair of 10s that can come out, and then who's going to stay in? The 21. If you want to break him down a little further, you can. So x equals 10 square root of 21 feet. On this one, since it's kind of a word problem, and like maybe we really do have like electricians working, you might be asked to put an approximate answer, because if you tell the electrician, oh, attach the wire at 10 root 21 feet, they're like, what does that even mean? So can someone throw that in their calculator? What's 10 times the square root of 21 to like 1 decimal place?
45.8.
Thank you. So 45.8 feet. So my math lab might ask you for an exact. Exact would have the root, so that's the exact answer. Or they might ask you for an approximate, which means put it in your calculator and get an approximate answer. So like, even though the antenna is 75 foot, we're only putting the supporting wire about 45 feet up, and that's what it is.